Alright, so we're going to pick up with volume computations. This is section 26.9. So in the beginning of the chapter, it showed a cross section, and I'm going to show you what it looks like. It's back here in the very beginning. Right here. Alright, so it's between 10 and 13. Remember, this area was a fill, and then it transitions from a fill to a fill and a cut on both sides to a cut and then a cut all the way out. So the table is set up based off these stations. So 10, 11, so there's 100 feet. It starts changing here at station 11 plus 21. 11 plus 40, 11 plus 64, and then this goes all the way into a cut. Alright, so they set it up like a table. So, to illustrate the procedure, assume the N areas are column 2 and 3, and I'll explain what those are. Alright, so at station 10, this is the area. So they already figured the area is 992 square feet. At station 11, again, this is still a fill, is 421 feet. Then at station 10 plus 21, there wasn't a cut, it still was a fill, but that's just kind of where we were going to transition. So you notice there's a lot of fill here, 992 square feet. And when they get here, we only have about 68 square feet. Now at 10 plus 40, we actually have a cut. So in other words, they're cutting in the ground. That would kind of look like, so if I was drawing a cross section, the left, it didn't show me which side was left, but it might be one looks like this, and then the other comes down. So one would be a fill, and then you would have a little bit of a cut. So that's kind of what that would look like. Then when you get to, so in other words, we have a cut and a fill. We got a little bit of both. And then when we get to the 11 plus 64, we're all in cut. So in other words, we're cutting down. We'd like to make these numbers kind of balance out. That way we don't have to bring so much fill in. Alright, so we want to get our area and volume. Anything that's a fill. So I think I told y'all when I was doing a job, I didn't add in, I actually just figured out how much fill compressed down they needed. But actually they calculated by dump trucks, and they're adding in like a 25% increase. So in other words, they're going to have to bring in, let's say, if it needed 100 cubic feet, they would need to bring in 125 to compress it down. Alright, so I'm going to make this a little bigger, and I'll explain why. So the formula, and I've got it right up top, to get the volume is your area 1 plus area 2 divided by 2 times L times 27. So if I take the area, I call this one my area 1, 992, and this one my area 2, and of course there's 100 feet between the two, and then divide it by 27, there's where the fill of 2614 comes into play. So if I say area 1, 992, plus 421, divided by 2, multiply that times 100, and divided by 27. That gives me, I got 2616.666, so it's round. Now, if we need to bring in 25% more, The easiest way that I do that is I multiply it by 1.25. So that gives me 3270. So right now I have a 3270 right here. All right, so when we go to the next one, we need to figure out what the area is between 11 and 1125. So I've seen some students where they'll do this area and they'll skip down and do this one and they miss the area between 11 and 1125 or 1121. So if I'm going to do the area between these two, it's 421 plus your 68 gives me a total of 489. I got to divide that by 2. Now my distance this time is only 21 feet because it's 11 to 11 plus 21. So times 21 and divided by 27. So I've got 190.16 cubic yards. And then we want to multiply that times your 1.25 because we want 25% more. And that gives me a 237.7, and they rounded up to 238. So again, for this particular one, we've got, a 0 cut here. This is where it transitions, so you'll actually need a 0 here. And that way we can take an average of the two here. So 0 plus 34 is 34. And divide that by 2 times 19 and divide it by 27. So I'm getting like roughly 11.96. Now that's the cut side. We don't add a factor to the cut side, only our fills. So I still got a fill on this side, so I'm going to write my 12 here. And we're still going to have our fill right here. So again, 68 plus 31 divided by 2 times 19 and divided by 27. That gives me roughly, I got 34.5 feet. And they've got 37. Let me check my number. They got 29. So let me check my two numbers. 68 and 31 divided by 2 times 19 divided by 27. Yep, I'm getting 34.8. And they've got 29. So there's something weird with that. My numbers are right, so it's got to be something in the table. So 34.8 times 1.25, because we've got a factor, that would be around 43.54. So this should have been 33.54. Everything else has been lining up. All right, now again, I've got 2 cuts, and then I've got a fill here. So I'm going to do the cut first. So 34. So what happens if they're cutting, they're using material that is actually on site. They're cutting it, and they can actually use that to fill in other areas. So we'd like to get a balance of cut and fill. That way we're not having to haul a bunch of dirt from off site. So if it all has to be filled, then that's a really expensive job. But if you can balance it out, and where you're cutting down on some and you fill in the other, then it would balance out. And that's kind of how we're checking it right now. So I took an average of the 34 and the 144 times 27, because I took the difference between the two stations, and divided by, or times 24 divided by 27 gives me 79.11, so we're good. And now this will be my last fill volume right here. So that would be 31 and 0 is 31 divided by 2 times 24 divided by 27 put in cubic. So it gives me 13.77, which is roughly 14 times 1.25, and I've got 17.22 or 17. So that's how you would compute them. So we would keep going down computing, and then once I get here, then all I'm going to have is cuts. For the next one, it will be a cut 553, and then between 12 and 13, that would be a cut 2,964. And then now how to do a run-in tabulation. So how they do that is they start with, right now we've got volumes. So we're going to use this volumes for here. And then we'll use these last three, or these cuts for this one. I'm not doing the middle one because remember we added 1.25. So if I say 0, and usually fills is a negative. If I say 0 minus 3268, I'm going to be a negative 3268. And then I'm going to subtract out a minus 2.38 to get a negative 3506. And then I'm going to subtract out 37, and I'm at a negative 3537, or 31, excuse me. So let me 0, subtract. You're going to always subtract the fills. Subtract 238, subtract 37, and that's where I get, I get in 3543 right here, and that might be where they had the mistake. Oh, you know what? I have a cut right here I have to add in. So when I got here to the 3506, I subtracted 37, but you also have a cut. This is the first column that had a cut. So if you add the cut to it, you're going to get a negative 3531. So I'm going to go ahead and add the next cut, which is 79. So I'm taking the 3531 plus 79 minus 17, and that should give me, I got negative 3469. The next one is just all cuts, so I'm going to add 553 for negative 5. So once I subtract all them, you add your cuts. So if I'm at negative 3469 and I add a 553 to it, that's giving me 2916. And if I add the 2967 to that, I'm at a plus 51. So I don't know how they got this number, but the end number would be 51. So in actuality, we would have enough. We would have more cut on the job to where we wouldn't have to bring in. So here it tells you, column 6 we did a factor of 25%, and it seems like there is a cut volume in excess of 51. So we'd actually have 51 cubic yards to play with out there and wouldn't be required to bring any fill in. So that's a pretty simple way to do that. Borrow pit is the next one, unit area or borrow pit. So here's an example. They've got, they did 20 by 20 sections. So a borrow pit is taking an average of 4 depths down. So if I wanted to find a volume of this area right here, we would, and I've made some notes for you, it's going to be the volume, it's going to be a summation of all 4 corners. So that's what that means, summation. So I would add, let's say if I got 2, 2, 2, 3, 4. I would add all 4 together. I would multiply it by the area, which is the area of one shape, which would be 20 by 20. I would divide it by 4, and the reason it's 4 is because that's a square. If you've got 4 corners, you're averaging it by 4, so that's a constant when you're doing a square. And I multiply it by 27, that's to change it in cubic yards. Now, so you can take 4 corners, 4 depths down, you can go and measure down in the hole at 4 corners and get a length and width and figure the volume. So you're just taking an average of all 4 depths and then times by your length and width and divided by 27. Now, not everything fits out in a perfect square, so some of these might have triangles here. So the only difference is when we do a measure down for a triangle, you're going to have 3 sides. And then your area of your triangle is 1/2 based on height. So I'm going to show you that right quick. So if I'm doing the volume for one that's a triangle, it would be the sum of your heights or measure downs. You'd be H1, H2, H3, and instead of 4, you're going to divide it by 3 because you got 3 to average, and then the area be 1/2 based on height, which is your triangle. And I'll go over that in more depth in another video, but this kind of gives you just an idea of how to do it. You could make them all separate figures and try to solve each one. Triangles, you do have to solve them all by yourself. They can't be combined together. They need to be done separately. But areas that have the same shapes that are close together, we can put them together and try to make our computations as least as possible. And then the last thing we're going to go is a volume by contours. And so I'm going to go over this one real quick, and then I'm going to work a problem. So in the book, the one I scanned in, and this is actually a sample, which is example 26.4. So this is a proposed dam, and they're trying to determine the volume of water that would be impounded by the reservoir. So in other words, what the top of the dam would be. So the top of the dam is 940. The bottom is 910. The top of the dam would be 940, and we want to figure out the area in between. Now what they did is they took a little, this was a map to scale, and they did a planometer, and they scrolled around and got an area for the volume. So they went around the outside and calculated a conversion factor, like it came out, and I'll explain that in a minute. And they wrote that down for each of these. So they set it up in a column. So basically the map was 1 inch equals 500 feet squared. So 1 inch squared equals 500 feet because it's a 1 to 500 scale. And then there's 43,560 square feet in an acre. And so I don't think we're going to have anything. And then we're going to do our acre foot. So I wrote this down because this was missing the chart in mine. So what you would be given is you'll be given the area. So what they did is they figured out, they did the little planimeter on the paper, and they got 1.68 inches squared. Now to get it to acres, you need, it's a 1 inch equals 500 feet squared was the scale. So I'm actually going to do, I'll show you, I'm going to do 500 squared and divide that by 43,560. And that gives me 5.739. So there's the conversion right there. They take that 5.739 and multiply it by each of these areas that they had calculated by the planimeter. So if I times that by 1.683, you'll see that's 9.68, 9.659. So you would multiply the 5.203 back by the 5.739. So 5.739 times 5.208, and it gives me 29.889. And you just multiply each one of these two by your 5.739 to get your acres. All right, so if we had something, a lot of times I like to just do my acres at the end and divide it by 43,560 at the end, but for this particular one, we would need to do it ahead of time. And then to get the volume, so you're going to just use, to get volume, we're going to basically use it by area averaged in. We're going to take an average of these two areas, divide it by 2, and this is acre foot, so it's not going to be volume or cubic yards. So we've got it in acres, so we're going to add these two, divide it by 2, and you're going to multiply it by the difference between the two contours. If this is 910 and this is 920, that would be 10 feet. So that's where you got acre foot. So if I say 9.659, now I'm going to go ahead and I'm going to come over here and show you that. So if I do okay, 9.659 plus 29.889. These are both acres. We're going to divide that by 2 times your length. And that's going to be in feet. So it's 10 feet between the contours. So there's no dividing this by 27 because we want it in acre foot. Then my area would be 197.7. So then we'd come down and do the next two. So 29.889 plus 64.598 divided by 2, and it's times 10. Because there's 10 feet between each of these contours. We've got a 910 to 920, a 920 to 930, and a 930 to 940. So just pay attention to your contour interval. And this one was 10 feet. And you should get 472.4. And then the last one would be 64.598 plus 110.246 divided by 2 times 10. You should get 874.2. And then you would just total all your volumes up. So if I total all those up, I've got 1544.3. Alright, so I am going to work a problem in the back of the book. So I'm going to minimize this and make my screen a little bigger here. And I'm going to work one that's problem 26. Let me make some more room for my paper. Okay. I'm just going to go ahead and scroll it out. Alright, so I'm going to work page 797. This is problem 2625. Alright, I'm going to set this up in a chart form, kind of like they did. So I'm going to set up, I'll show what I'm going to do. I'm going to set it up and put my contour intervals here and then my area here. And then I can do a column for my average. So it wants to compute this in acre foot between the two. So it wants it in acre foot. Alright, so I'm going to come up and this is 86. So this is contours. 87, 88, or 880, and this is my area, and it's already in square feet. That would be 1370, 1660, 2293. Come on down and finish these out. 890 is 2950. 900 is 3550. 910 is 4850. Alright, so I'm going to make my next column my volume. I'm going to put the volume at the end. So I'm going to take the average of these two. So 1370 plus 1660. You're going to divide it by 2, and the difference in elevations is 10. So just like that. So 1370 and this is acre foot. I'm going to kind of check off. It's easier to do this one in a chart. I'm going to kind of check off, make sure I got everything. Oh, actually, I'm not in acre foot yet. I'm actually in, let me take that back. I'm actually, if that's square feet and my distance is feet, I'm in cubic feet. So I might want to go ahead and convert my areas to change my areas to acres. Let me do that. Oh, got a mess here. Okay, so if they want the volume in acre foot, I would go ahead and multiply and put these in acres. So that would be dividing it by 43,560. So I'm going to go ahead and do 1370. Well, actually did it. They did do it, and there's a couple of ways you can do this. 3, 4. That would be acres. And then 1660 divided by 43,560. That would give me 0.0381. Now if I take those two and add them together, divided by 2 times 10, so 0.314 plus 0.381 divided by 2 times 10, sorry, missed my 1 in there, 0.0314 plus 0.0381 divided by 2 times 10. That answer would be 0.3475. So that's probably going to be the best way to do this. So if I do the next two, we've already got that converted. I just need to come down and convert these all to acres. So 2293 divided by 43,560. I got a 0.0526. I'm just rounding. 2950 divided by 43,560. So just pay attention on what they're asking for. And I think your problem I gave you is going to be the same thing. And there's probably a couple of ways we could have solved this, but I'm going ahead and changing it to acres before I add them together and divide by 2 and then times it by the distance. So I'm at 0.1113. Alright, now I can come back up and I can take an average of these two. 0.0381 plus 0.0526 divided by 2 times 10. 0.381, make sure to put the 0.0381 plus 0.0526 divided by 2 times 10. And that's 0.4535. Now I need to do the one between this one and here. So 0.0526 plus 0.0677 divided by 2 times 10. 10 feet between contours. 0.0526 plus 0.0677 divided by 2 times 10. That gives me 0.6015, and this is acre foot, and then we can add them all together. Got 2 more calculations left and we're done. So 0.0677 plus 0.0815 divided by 2 times 10. 0.05 I could have noticed that 2 divided by 10 would be 5, and that could have made it a little easier. And my last one. Hopefully I got everything right. Close to what, very, very close to what the book has. And that would be 0.964. They actually kept it out to 5 decimal places. I kept mine to 3. So now if I total these up, 0.964 plus a 0.176 plus a 0.6015. Let me punch my numbers again. I got 308. So my grand total is 3.0825 acre foot, and they had 3.11, so it's a difference in rounding. Alright, so that's the end of all of chapter 26 in a nutshell, and we'll work on bar pits on Monday and anything else you want to talk about on Monday.